2.12. It's all about motion with constant acceleration. Okay, here as you can see, the motion with constant acceleration have the following consideration. We know that for motion with constant acceleration, one thing that you need to consider is the velocity, speed per direction changes. The velocity changes at the same rate, throughout the motion. This means that, for example, in 1 second it may be 10 meters per second, in 2 seconds it may be 20 meters per second, so you have to expect that at 4 seconds it should be 40 meters per second. This is a velocity change, should be considered at the same rate for motion with constant acceleration. Okay, the other thing that we need to consider, average velocity, average acceleration, over any time interval, is equal to, remember, is equal to the instantaneous acceleration. The instantaneous acceleration at any instant of time. Okay, so having these 2 points in mind, that means the velocity change at the same rate throughout the motion, and the other one is average acceleration over any interval is equal to the instantaneous acceleration at any instant of time. So therefore we know that acceleration is equal to the change in velocity over change in time. This means that V final, change in V, is equal to V final minus V initial over T final minus T initial. Acceleration is equal to V final minus V initial, T final minus T initial. Consider T initial is equal to 0, therefore acceleration will be equal to V final minus V initial over T. Having these points, now let's rewrite. We know that the acceleration is equal to V final minus V initial over T. Multiply both sides by T, then it becomes acceleration multiplied by time is equal to V final minus V initial. V final minus V initial, multiply both sides by T. Then take this one from the right side to the left side, it becomes positive. This is minus. Here it becomes, when you take this from right side to the left side, it becomes positive. Therefore, acceleration times T plus V initial is equal to V final. Therefore, V final is V initial acceleration multiplied by T. Okay, so for motion, we have to consider a motion with, again, constant acceleration. With constant acceleration, the average velocity, because motion with constant acceleration, remember, the average velocity is equal to V final plus v initial divided by 2. This is formula for the available velocity in case of constant acceleration. Okay, so having this in mind, let's proceed. Having this in mind, we know by definition, the average velocity, by definition, the average velocity is equal to change in r value over change in t. Change in r value over change in t. Okay, let's rewrite this one again. V average is equal to change in r over change in t. Okay, so having this in mind, we know that for t initial is equal to 0, change in r will be equal to, for t initial is equal to 0, change in t is equal to t final minus t initial, where t initial is equal to 0, therefore it becomes t. Therefore multiply both sides by t, the average velocity multiplied by t is equal to change in r. So change in r is the average velocity multiplied by t. Now let's substitute the value of t and the average velocity in order to get change in r. Change in r is equal to, now let's have the average velocity in case of constant acceleration. The average velocity in case of constant acceleration is v final plus v initial divided by 2. 1 multiplied by this t value. But the t value can be taken from the other value, which is equal to, t is equal to, we know t means v final minus v initial divided by time. Divided by the acceleration. Which is taken from the previous formula, where we know that here as you can see here, acceleration is v final minus v initial over t. Therefore replace, now exchange the place, so t will be equal to v final minus v initial over the acceleration. T will be equal to, from this we can rewrite again, t is equal to, here we can write t is equal to v final minus v initial over the acceleration. Take this one here, the acceleration here. So it becomes t is equal to v final minus v initial over the acceleration. Therefore, change in r is v final minus v initial over v final minus v over the acceleration. Now multiply these two, considering the vector value. So it becomes the r value will be equal to, let's proceed to the next one, which will be equal to, change in r will equal to v final square minus v initial square divided by 2 times the acceleration. And this is taken from the formula where a minus b multiplied by a plus b is always mathematically, a minus b multiplied by a plus b is always equal to a square minus b square. So we have v final plus v initial and v final minus v initial from the previous. Let's see once again, v final plus v initial, v final minus v initial. So v final square minus v initial square, like mathematically we have a minus b multiplied by a plus b means a square minus b square. So change in r will be equal to v final square minus v initial square divided by 2 times the acceleration. Okay, now let's proceed to the next one. We know that v final is equal to, now multiply by 2a, it becomes 2a multiplied by change in r. Take this one from the left side, this will be equal to, first write this v final square minus v initial square, and take this from the right side to the left side, it becomes 2 times the acceleration times change in r plus v initial square is equal to v final square. Okay, so having this in mind, having this relation in mind, now let's look the components in the direction of x, the direction of y for acceleration as well as velocity. We know that acceleration is equal to the components in the x in the I direction, and the acceleration is the component in the y. So indicate by this one j. So ax in the I plus ay in the j. Just like this, v final also can be written as v final. The vector v final is equal to vx final in the I plus vy vy final in the j. The initial can also be written as the initial vx initial in the I plus vy initial in the j. Remember, for acceleration we have x and y. For v final we have again x and y. For v initial we have again x and y. So the other final, initial. So the only thing that we have a component in the x, in the y for v final. For v initial also we have a component in the x and in the y direction. The acceleration also has a component in the x and in the y direction. So there is also a consideration in the z direction. If you consider z in the z direction, it becomes acceleration ax in the I plus ay in the j plus az in the k. Az in the k. That also possible. That means it's possible to write also like plus this value, which is az in the direction, az in the direction of k, plus this one also we have v, this is v final, so it is y we have, and the only thing that left is z final in the direction of k, plus this is also the initial value vz initial in the direction of k. So this is also possibility to write in such form. So having these points in mind, it is possible to write the v final. We know that v final is equal to v initial. V final is equal to v initial plus acceleration multiplied by t. V final is equal to v initial acceleration multiplied by t. So based on this, we can rewrite that. Based on this one, we can write considering the x and y. Now let's start from the x. Vx final is equal to v final. Vx final is equal to, we have initial, so vx initial vx initial plus vx final is equal to vx initial plus, we have to consider the acceleration only in the x multiplied by t, x multiplied by t. The other one is in the y. Vy final is equal to vy initial. Vy initial that we need to consider is in the y direction, ay times t. Ay times t. Remember, this is v final, so x. So if it is considering the y, it becomes vy final, vy initial, ayt. If you consider additionally vz final, it should be equal to vz initial plus the acceleration also should be written az multiplied by time. Az multiplied by time. Okay, so these are the very important points that we need to consider. Now let's proceed to the other important point, which is regarding the change in R value. Change in R, which is equal to R final minus R initial, which is equal to, again, this is V initial multiplied by time, vector 4 plus half the acceleration t square. So this is change in R, so it should be written in such form. Now let's look the components for this in x, y, and z. Now let's start from x. Change in x instead of change in R, let's say change in x is equal to, we have v initial times t, so we need to consider vx initial multiplied by t plus half times, so the acceleration that we need to take for is x t square. What about if it can change in y? If it's change in y, instead of vx, we have to take vy initial times t plus half multiplied by ay t square. If it is change in z, it will be equal to vz initial times t plus half az t square. So based on this, we can solve different questions. So the next lesson will be the question based on this